The thermohaline circulation has a big influence on our climate. But what is the thermohaline circulation exactly, and by what is it driven? These ocean currents are driven by the wind, the density of water, and the rotation of the Earth. The wind influences the current of the water by as deep as 400 meters. The Gulf Stream is the most important current for Europe. Westerlies blow the water northwards towards the northeast, causing the Gulf Stream to flow with 2 meters per second, bringing up to 100 million cubic meters per second of water to Europe. When the water reaches the cold north, the crystallization of the water molecules, or ice formation, causes a higher salt concentration in the leftover water parcels. The higher salt concentration, in combination with the colder temperature, increases the density, causing the water to sink. Now that we know what the Gulf Stream is, let's see why it is important for the climate in Europe. This thermohaline circulation is responsible for much of the total oceanic poleward heat transport in the Atlantic, peaking at about 1.2 petawatts at 24 degrees N. This current brings the amount of heat to Europe that is equal to the amount of energy that 1 million nuclear power plants supply. This indicates the importance of the maintenance of this heat supply to Europe. Due to climate change, the ice sheets in the Arctic are likely to melt. Especially the melt of ice sheets near Greenland, in combination with increased precipitation, are of importance for the Netherlands as they influence the Gulf Stream. Both phenomena decrease the density of seawater. This causes the water not to sink as deep, creating a cold surface stream. This can cause the Gulf Stream to stop transporting warm water to Europe. The effects are yet unknown and depend on a lot of other factors. Possibilities are changing cloud and precipitation patterns, decreased temperature, and sea level rise. Scenarios are simulated where certain tipping points are reached, leading to rapid shifts or disruptions in ocean currents. These disruptions are linked to the thermal and haline circulation of water. In the current state, the thermal component is more dominant over the haline component. However, due to climate change, the thermal gradient between the equator and the Arctic becomes less. This makes the haline circulation relatively stronger, which in turn could result in a so-called bi-stable regime, where the thermohaline circulation is either on or off. Some modeling suggests that climate change may switch the THC, thermohaline circulation, to an off state. A 2023 study suggests that for the Gulf Stream, this off state might occur within this century. This research uses both the global sea surface temperature and the temperature of the Northwest Atlantic Ocean, as well as a business-as-usual scenario for climate parameters, resulting in a prediction of the off state, which has a 95% confidence interval to occur between 2025 and 2095. The KNMI has modeled what would happen to the Netherlands in such a case of abrupt change. Their model predicted a temperature decrease of 3 degrees Celsius for Western Europe. Together with anthropogenic warming, a total cooling of 0.5 degrees Celsius was predicted. Other models suggest that there is little or no THC reduction, despite increased greenhouse gases, possibly due to negative feedback mechanisms, like changes in ENSO or Northern Hemisphere atmospheric variability patterns. The KNMI stated that based on Gulf Stream data over the last 8,000 years, the risk of an off state in this century is not large. The idea of a worldwide catastrophe, as depicted in movies like Day After Tomorrow, is an exaggeration. Modeling scenarios vary, and while changes in the THC can have significant climate impacts, extreme scenarios depicted in movies are not considered probable. Also, the slowing down of the current may have a cooling effect, which can decrease the effects of global warming. Ongoing research aims to refine models and better understand the potential consequences of THC changes in the context of global warming.